Welcome back to the academic powerhouse with the realest guy in the room, the mathematical meathead himself. Bada bing, bada boom. How you doing? Let's talk about that homework. Let's talk about those homework problems. Here are the worked solutions, step by step. I'll run through it. Don't want to leave you hanging. Want to help you out, help you understand, and ascertain the knowledge that you seek. So let's start with number one. Before we start this whole assignment, reminder about calculating surface area and volume for prisms and pyramids, and I even threw in a cylinder or two. Okay, so let's roll through it 1 through 18. Hopefully you did well, but you can sort of see. Ooh, wow. Okay, you can sort of see here that, bam. All right, first one here. The key to these is you gotta really dissect how the diagram is, what you're being given in the diagram. Sometimes these things can be a little tricky looking, a little trick of the eye. When you stare at a 3D shape, I don't know. For me, it just kind of sometimes my eyes plays tricks on me. But this arrangement right here is correct. This arrangement here, I'll explain a little bit here. All right, so this arrangement here, the 5 by 12s, that corresponds to these big, huge faces here. And then the one here. Yep, see that there? Awesome. Okay, these little 5 by 2s, well, you can see there's the 2 here, right? It's telling you that this, this one here is 2, and then 5, so 5 by 2. There's 2 of those, right? Makes sense. And then you have to be careful because the other side of the long and skinnies are not the same. They're not the same. They're 12 by 2s. The 2s are the same. The length is a little bit different, right? This isn't a square object. This is a rectangular object with a square face. Anyway, so I like to draw out my shapes and group them up based on the number, or, the ones that are unique to them. So for every, so here I have this. This is one unique shape, and there's 2 of them. Drew them out, circled them, right? I have it color corresponding over here, right? Color corresponding, just so that as we roll through these, you can make that visual connection, right? I again draw them all out, group them up, and there you go. So, anyways, erase, erase, erase. Okay, so let's talk about this. So as long as you know the areas of, or how to calculate areas of squares, rectangles, triangles, and circles, you'll be good. Right? It's the way I've written it out is a really good way to organize your thoughts and your work. Right? So I kind of organize it such that I'm very clearly working on one type or one of the unique types of shapes at a time. Right? I recognize that there's 2 of them. Right? 2. There's 2 here. Okay, that's where that 2 comes from. Length and width is given to us as 5 and 12. Calculate, calculate, you get an answer. And you repeat the process for each unique grouping of shapes. This number on the outside will change depending on the count of shapes. You'll see as we go through, this number on the outside of the parentheses will change. That's so. Bada boom, you plug in some numbers here. You get answer, calculate, calculate, calculates. So for each type of shape, here we go. That's what we got. Now, at the end, all we do is just add them up, add them all together to get the surface area. Right? So 120 plus 20 plus 48, add it all up, you get the answer. Not too bad. I think the key, again, once again, is dissecting what the diagram is telling you and then organizing your work in a way that so you don't get lost and you don't forget things, right? If you lay it out in a nice organized fashion, then you won't forget stuff. Number 2 and 3, here we go. All right, so you can kind of see, all right, there's some variation in the counts of the shapes that are being laid out. I've got, this time I've got 4 8x5 rectangles, right? All the rectangles here on the side of this rectangular prism. Whoa, hold on, scrolled a little too far here. Scroll back. There we go. Anyways, so yeah, there are 4 of them. And then the tops 8x8s, right? The tops. So there you go. Actually, these aren't the tops. These are actually 2 of the sides. Let me make that clear. These are not the tops. The 8x8s, right? It's saying that this is 8 and this is 8, which makes this therefore 8. Um, and this is 8 based on what this is, right? So this is an 8, this is an 8. So those 8x8s are this one, and then the opposite side of it, this one. The rest of them are the 8x5s. A little strange looking diagram. Again, it's easy to get lost. In the diagram, you really have to pay attention and dissect it appropriately. Anyways, so grouped them all up. Got my greens, got my purples. You see the 4 there lines up with the number of shapes, right? 1, 2, 3, 4. Oh man, my pen is not behaving nicely today. Okay. All right. There you go. You got the 4 and you got the 2. Plug in the right numbers. Add them up at the end. So you got, so for each shape type, got my 160, got my 128. You see them here. Added them up, and I got my 288. Same idea. Well, same basic steps for all these, at least surface area. It'll change a little bit when we do volume. Right, dissect the shape. Here I can clearly see 2 triangles. It's actually a triangular prism. You can see 2 triangles. It tells me right here what the values are for the base. Right, that's an 8, which makes this an 8, and that back there is a 6, which makes this a 6. Right, if you can kind of see it. And then now the thing about these prisms, triangular prisms, especially these right triangular prisms, is you have to pay attention to the, I'll call them the long and skinnies, or even rectangles, I guess, for lack of better words. But they're all different. They're all going to be different because each of the sides of the right triangle, usually, that you'll be given on your problems, usually they'll all themselves have different heights and different bases in measurements. So therefore, you would typically expect to see 3 different variations on a problem like this. This would be a typical right triangular prism sort of problem. Anyways, 2 triangles. Remember our formula of how to find a area of a triangle, 2D area of the face. There you go, 1/2 base times height. Plug in the right numbers. Again, there's 2 of them because there's 2 triangles. 8 and 6, 8 being the base, 6 the height. Calculate, calculate, get a 48 at the end. Got my 3 rectangles here. Each one I did separately. 40, 50, 30. Okay, now just a matter of bring them all down here, add them all up. Add them all up. Not too bad, you get 168. Number 4. This one, it's not quite a cube. Not quite a cube. It looks like it though. You have to, again, pay attention to the diagram because at a quick glance, oh yeah, they're all 8s. Nope, it's a 9 right here. It means it has significance, right? Anyways, break them all down. I got 2 versions of 8x8s, which are these big faces here. Right, these big, huge square faces here. on either side, and then the rest of them are all 9 by 8s, right? This top one, this one here, this one that wraps around. Again, hard to really see it unless you unfold it. That's why I've drawn the shapes out separately. Anyways, plug stuff in, or sorry, create my general formulas here for each of my groupings. Square, I said blue here. I think I meant rectangle. Either way, each of my groupings, got 2, got 4, makes sense. Plug in the numbers that were given to us in the diagrams. My green squares come out to be 128. The blue 288. Add them up and get 416. That is it. Okay, now we're moving on. Prisms, not too bad. Surface area when it comes to pyramids, though. Well, again, they're not too bad, but they could maybe be a little tricky. I don't think they're too bad, though. But anyways, the setup is the same. Break out the component shapes, group all the same shapes together, just like this here. And, right off to the side, right off to the side, right? Bam, right there. Squares and triangles, 4 triangles, 1 square. Plug in the dimensions given, calculate, get some numbers. 81 plus 135 is 216. Fairly standard uh, square pyramid. Fairly standard square pyramid. Now here, well, same, actually, the very same. Actually, yeah, this one is the same. Different numbers, same exact thing though, right? 1 square, 4 of the same exact triangles. Get 100, 224, add them up, 324. This one's a little different. This one could catch some people off guard. Well, when you have a pyramid such as this, then you will often have differing triangles on each side, right? Because it's just the way rectangles work. One side is longer than the other, and so if you have triangles on the outside of each of them, the ones on the further away sides, them triangles themselves have to be slightly longer to reach for all the tips to reach up here at the top, if that makes sense to you here, right? So they all meet at the tip right at the middle because this side is further away from the center, right? It's got to be a little longer to get that extra reach. Anyways, just a little sidebar. But it's important to know because you have to recognize you're going to have 3 different groupings of shapes. And if you're not careful and you instead say that they're all the same triangle, well, you're going to get a really crazy number. So recognize there are 3 groupings, right, based on the diagram that's given. So I got my 3 groupings off to the side, 1, 2, 3, and get some numbers here, 120, 134, 156. Add them all together, and I get 410. 410. That's about as complicated as a pyramid gets surface area wise. Another example here for number 8 where you had, actually I shouldn't say, let me back up. That is as complicated as you'll get for the pyramids I'm going to give you. Of course, as you go on in your math journeys, you'll have hexagonal pyramids and octagonal pyramids and all sorts of, those can get a little more complicated, potentially. But yeah, for the ones I'm going to give you, squares, rectangles, triangles, this is as difficult as they get. Recognizing that there's 2 different groupings of triangles will be the key on those, right? So you can see number 8 dissected the diagram. got my three little equation things off to the side, got some numbers in total, added them all up, 385. And then, of course, I'm going to throw a cylinder at you. Come on, guys. Just a little bit of fun here. So, cylinders, as we talked about before, right, they are composed of two circles. And if you unroll it like a can of soup, if you cut down the middle of a can of soup, you unroll it, and it just becomes like a big, just rectangle. So recognize that for one. Okay, you see here the diagram says 12 yards, and in my recreation, I put 6. Well, I did that because our formula for area of circle, which you'll need to know, this right here, pi r squared, right? I wanted to have an r in there so it was easy to see that you plug it in. But yeah, so that's why I did that. Anyway, so I did them one by one. Circles. Circles first, two. There's two of them, as you see. So just multiply by pi r squared, r being my 6, r being radius, radius being half of a diameter, which is, the distance that goes across, right? This 12, that's what a diameter is. Anyways, blah, 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 72 pi. Now the rectangle here, it's tempting to just want to put 12 yards or 12 just on the side of this rectangle. Understand you should put 12 pi because when you roll it up and when you unroll it, it's rolled around in the circular pattern, right? The circuit pi is this ratio that relates to circles, right? So you don't want to forget about the fact that this originated as a circular uh, rectangle, I'll call it, around the cylinder, right? So when you're doing your long side on these, do not forget to put the pi in, because if you do, you could get a miscalculation later, maybe. Anyways, so you can see here, I did that, and when I did that, I got the one rectangle, plug it in my dimensions, 9 and 12 pi. Doing so gets me 108 pi. So that when you then add these together, right? Remember combining like terms? Remember that? You don't want to do like 72 pi plus 108. You can't, that's not really consistent with the idea of combining like terms. Or even, actually even more accurate to say it's not really consistent with PEMDAS, the order of operations, right? Right? So what you are to interpret from this here is 72 times a number. Well, according to the order of operations, you do the multiplication first before that you add. Either way, don't have to spend a whole lot of time thinking about that. Just know that on your cylinders for your long side of your rectangle, just put the pi there. That's all for now, just to know. Okay, so let me do some erasing here. Got it. Okay, so easy day, right? Easy day. Now we're moving on to volume. Volume is this, let me scroll up just a tiny bit more so you can kind of see the general formula that I have here that I want you guys to sort of commit to memory. The general formula here is you can really kind of classify them for what we're going to do. Classify them in two different ways, prisms and pyramids. Prisms, you take the area of the 2D face and you multiply by the depth. If you imagine a stick of butter and you can spin it around on a plate, you can, there's a couple points when you're spinning it where you look right dead onto it and it appears as just a square, right? If you're, again, stick of butter, spinning it around on a plate or something. But as you continue to spin, you'll see that, wait a minute, it's not just a 2D square. You spin it just a little bit, you see some depth here. That's what this is, the depth. Depth. Depth is what gives 3D objects their 3D factor. All right, and volume is all about calculating, making calculations for 3D shapes. For pyramids, it's mostly the same. Well, it's the same idea as far as identifying the base or the face, you want to call it, and getting that 2D area of it. A little bit more to it than that. When we get to some of those, I'll talk more to it. But these first few problems are prisms. So diagram says 2 by 2 prism, or yeah, 2 by 2 by 2, basically, right? So all these faces are the same. Just pick one of them. Oops, pen is going crazy right now. Okay, there we go. Pick one of them. Do a 2D area calculation, which is this. Oh man, man, oh man, oh man. Okay, I gotta fix this pen later. Okay, but anyways, there you go. There you go. Comes out to be 8. Again, the 2D face area, 2 by 2, times 2 depth. Boom, boom, boom. Simplify, you get 8. Number 11 here. It is a right triangular prism once again. Now, if you thought before, when we did surface area, it was a little more complicated, it was, which is great. We're doing volume now, it's easier, right? Just do the area of the 2D face once, times it by the depth, get an answer, simple calculation here. Okay, so you can kind of see the steps I've taken. There you go. 12, it is a square prism, 6 by 6 square. Okay, that's these big, huge faces here. The 4 depth. Plug in, just plug away, guys. Plug and chug. 13, another right triangular prism. I want to make sure you guys are comfortable with those. So there's another one here. Dissect the diagram, build the base equation, and plug and chug, guys. Now we're getting to the pyramids, which I said I'll mention a little bit more. So the formula of a pyramid, again, you don't necessarily have to know the full details of it, but understand it is 1/3. The 1/3 has significance, right? If when people were doing experiments long ago trying to figure out how much volume a pyramid has, and they ran experiments and ultimately determined that a cube a pyramid with a 4 by 4 base pyramid can fit into a 4 by 4 cube perfectly well, right? Which makes sense, right? They have the same base dimensions. Um, and it's hard to draw, but basically the amount of stuff you can fit into a pyramid that fits exactly in the same base dimensions as a same base dimension cube, it's 1/3 less. Don't worry if it sounds complicated. I wish I had a way of showing you it. Nice little visual. I think I did mention it in my last video, but here we're just doing the calculations. Just don't forget the 1/3. That's really it. Just do not forget the 1/3. The 1/3 will, if you miss it, you'll get some crazy numbers, or you'll overestimate on your numbers. Anyways, and this height refers to the pyramid height from the very tippy top of the pyramid straight down to the middle of the base. So not the height that goes along the side of the pyramid to indicate the height of that particular triangle. Again, it's from the tip straight down through the object down to its base, almost like you're drilling a hole straight down. That is the height it refers to. Anyways, so boom. Dissect the diagram a little bit. Found my base. Arrow to my height, I should say. And then boom, plug and chug, guys, based on that formula. Same thing here. Well, actually, no, this one's a triangular pyramid. I had to throw one in, guys. Had to. I don't like the way these diagrams are, but I just had to throw one in. With that said, same steps. Instead of a square, it's a triangle. You know, it's got a base and a height. The triangle itself has its own formula, as we've explored before, right? 1/2 times base times height. Correctly identify all the values, dissect the diagram, start with your base skeleton equation, plug and chug, get 64 at the end of this thing. Two of them, actually you got two of them here. Same idea, right? It's same, it's a pyramid, triangular pyramid, both of these, same thing, slightly different numbers. Square, pyramid, very similar to before. I think I did one, right? Yeah, here it is, square pyramid, same thing, same thing. Dissect the diagram, 9 by 9 base, 10 height, plug and chug, 270 you get at the end. Okay, cylinder. Cylinder is basically the same as a prism. I say basically because really, when I think of prisms, I think of box-like objects that surround a face. And I guess technically that's sort of true, which is why I say that it is both a prism and a cylinder. But you'll see it most commonly written as cylinder, or talked about as cylinder. With that said, remember from prism, right? You just get the 2D face times the depth, which is what we've done here. Pi r squared times the depth. Dissect the diagram a little bit, find the right numbers, plug them into the right spots, get an answer at the end. 300 pi centimeters cubed. And that's the homework, guys. Not too bad, not too bad. Step-by-step solution. I hope seeing it written out like this helped. I hoped hearing me explain about it helped. But yeah, as 6th and 7th graders, you should be fairly comfortable with performing these calculations and working with these sorts of problems. So I hope you got a really good pump on today. You built up some of the mental muscles to proceed forward and continue on with your mathematical journeys. So thank you for stopping by. Have a good day. See ya.